Good morning and thank you for joining us today for this Solve It session webinar. My name is Rachel, joining us from Belzona's marketing department.
And I'm Henry, I'm from the engineering services department.
And later we'll be joined by Belzona's commercial director, Steve Cooper, for our Q&A session in about 20 minutes. So if you do have any questions at any point during the webinar, please type them into the chat and we'll answer them at the end. Today though, we're going to be focusing on concrete, or more specifically, damaged concrete. We'll look at some of the most common damage mechanisms which affect it. We'll put it to the test versus Belzona materials, and we'll examine a number of case studies from floor to ceiling where concrete was repaired with our 100% solids epoxies. So without further ado, I'll pass you over to Henry to look at some of the problems associated with concrete.
Okay, so the first bit we're looking at is, as Rachel said, the problems that are associated with concrete and how it becomes damaged, or the damage mechanisms. So the first one we're going to look at is freeze-thaw damage. This is, again, a very common issue to find throughout industry. So this occurs mainly at the lower end of the temperature scale. As the moisture gets inside the concrete itself, that freezes, and obviously ice takes up more volume than water. So as it freezes, it expands inside the concrete, and then it effectively pushes the concrete apart from the inside out. In most cases, this causes the damage you can see in the pictures. So the concrete can no longer hold itself together, it cracks internally, and then you get spalling of the concrete as it falls away from itself. So damage to clarifiers, steps, overhead areas, it's all the same, it's all due to moisture damage. Following on from the moisture theme, concrete requires moisture in order for it to attain a full cure. There's a very set mixing ratios for concrete to get a good mix with a good mechanical strength after it's cured. Now, the strength of the concrete is entirely dependent on this moisture content. If we have too much, you tend to find that the concrete may stay wet for a considerably longer amount of time. Or if you have too little, it may evaporate too quickly for the concrete to attain its full mechanical properties. And now this is the point where you tend to get shrinkage in the concrete. So you've got rapid evaporation, and again, the concrete tries to fill in those gaps, and as it does, it shrinks. And as it shrinks, it pulls itself apart, much like in the freeze-thaw damage. You get internal stresses which cracks the concrete and causes it to fall apart and break away. Because of this, you lose some of the mechanical strength of the concrete, meaning that, again, it can't withstand the sort of industrial environments that it's normally placed into. Again, sticking with the moisture theme, so carbonation is a massive problem throughout industry. So it affects pretty much all types of concrete, regardless of where it is, but it's the most damaging on reinforced concrete. So what we mean by reinforced concrete is any concrete which has a structural rebar or steel going through the centre of it to give it that extra structural capability. This is caused mainly by moisture and CO2 absorbing through the pores of the concrete and getting down to the rebar. Now, concrete is normally quite alkaline in nature, and what you find is that the passivate layer that sits on the top stops the corrosion from happening. If you lower this alkalinity and make it more acidic, you lower the pH level of the concrete, you tend to find that the passivate layer disappears. And once this disappears, it's effectively like not having a coating anymore. That rebar starts to corrode, the rust expands inside the concrete, and exactly the same as the freeze-thaw damage and shrinkage damage, you get spoiled concrete as a result. And this then exposes the rebar, which then causes it to rust further, and it's a vicious cycle at the end of the day. More on the mechanical side of things, so we have abrasion. So abrasion is a major issue in an area which involves heavy machinery or types of transports. Heavy duty materials that are used, and then repeated contact causes this concrete layer to wear down over time. But as you said previously, this allows the moisture to penetrate further into the concrete. And again, it's another cycle. So you remove that top layer, moisture gets in, that damages the concrete, that next layer gets removed, moisture gets in, and it's just a vicious cycle afterwards. So you get wear, repeated contact and wear over time. As I've already stated, concrete is a very alkaline material, so you change the pH and it messes about with the binders inside the concrete itself. So this can actually cause it to lose its mechanical properties purely from contact with a chemical of some description. So you change the pH level, you affect the binder of the concrete, and if you affect what holds the concrete together, then it's either going to dissolve into the chemical itself, or you're going to lose your mechanical properties. So if they're reduced, you'll find again that impact damage, abrasion, freeze-thaw damage, shrinkage all become a major issue and become much worse in the presence of certain types of chemicals. And then finally, as you can see in the pictures, impact damage. So concrete is known for its fantastic compressive strength. So you can hold a tremendous amount of weight over quite a large area without any sort of mechanical failure. The problem comes when all of this force is all concentrated onto one small area rather than spread across a sizable area instead. So this impact force can be enough to fracture the concrete completely, or in a lot of cases damage it just on a structural level. So once the damage has taken place, as you can see in the pictures, it's going to be very easy for moisture to then get into the concrete, and again, it's starting that vicious cycle of damage and then moisture ingress, which causes carbonation, shrinkage, freeze-thaw, and all the damage mechanisms that we've just discussed.
Okay, so now we've explored some of the issues that concrete can experience, we want to look at the solutions, how to fix it. Like-for-like concrete repairs are often favoured, but these often struggle to adhere to the existing substrate. Besides, what's to stop the same damage from happening again? Belzona has created a range of 100% solids epoxies for mortar repairs as an alternative to traditional rebuilding. These epoxies are designed to restore concrete structures, protecting them and prolonging their lifetimes. And rather than individually trying to solve every one of those issues Henry was just discussing, Belzona have created just a handful of versatile systems which can be used to treat an infinite amount of problems. So our solutions are designed by area to cater them for the necessary repair. So, for example, overhead and vertical damage can be repaired with our lightweight mortar, Belzona 4141. For large areas, we have Belzona 4154, a bulk fill material. Smaller repairs can use Belzona 4111, our classic nifty mortar repair composite. Or if you need to screed an area, Belzona 4131 was designed for that. Our materials can also protect against chemical attack. Belzona 4181 is a chemical-resistant screed, or you can use the coating Belzona 4311 on top of another material. However, I am aware that these might just be a bunch of numbers to you, so rather than just telling you about our products, we decided to put them to the test versus like-for-like repairs, so you can see how they perform in a video. Just as a warning though, before we play the video, the volume is automatically very loud, so please turn down your volume now, and then remember to turn it up again when the video finishes.
Concrete is the most widely used construction material in the world. As a consequence, concrete damage and deterioration are perhaps the biggest problems encountered by buildings and structures. From floors and steps to walls and roofs, the effects of damage are clear to see across multiple areas. But is more concrete really the answer? As an alternative to like-for-like repairs, Belzona offers a variety of polymeric mortar repair and protection solutions. These materials offer superior application and performance benefits. In this video, we put some of these to the test. For vertical or overhead applications, concrete is impossible to apply and cure without the use of formers and shuttering. Instead, Belzona's materials can repair the damaged area with minimal support and fully cure without any shuttering. For example, this high-build concrete repair material will not sag, even when applied thickly on vertical or overhead surfaces. The lasting quality of Belzona is better too. All of Belzona's mortar repair systems demonstrate excellent levels of adhesion, even on vertical and overhead surfaces. In fact, Belzona adheres so well that it's stronger than the cohesive strength of concrete. Lightweight properties also make Belzona superior to like-for-like concrete repairs. When fully cured, Belzona's low-density polymeric system weighs significantly less than the equivalent volume of concrete. Lighter materials make applications easier and quicker. Even light pedestrian traffic can result in deterioration over time, yet concrete areas featuring heavy-duty vehicles can be prone to higher levels of wear. Belzona can prevent this problem from reoccurring with rebuild materials that provide long-term resistance to both abrasion and impact. Loading bays and storage areas make excellent examples where these solutions have proved beneficial. Whether exposed to the environment or aggressive chemical contact, Belzona's concrete repair composites are non-porous and do not absorb water or chemicals. This makes them ideally suited to areas subject to chemical attack. In fact, Belzona's range of mortar repair materials and coatings are capable of resisting some of the strongest acids and alkalis used across industries, even at high temperatures. For each application area and service environment, Belzona offers a superior solution to repairing and protecting damaged concrete. And as demonstrated, you can be guaranteed that these benefits will come as standard. Visit belzona.com for more information.
So that video was all real results, no movie magic to make the Belzona come out on top. However, we also wanted to show you some case studies from around the world so you can see how Belzona can be used in practical, real-life scenarios. So Belzona has a fantastic library of case studies, all available to the public at khia.belzona.com. An independent online case study library, indussolutions.com, actually found us to be the 4th largest provider of case studies in the world, sandwiched between Microsoft and GE. And that is how dedicated Belzona is to sharing information about our applications. So if you're interested in finding out some information, some Belzona case studies, it's a really easy to use website. Just type in some keywords and a number of similar applications will pop up. So this takes us back to the poll at the beginning of the webinar. So we asked you how many case studies you think Belzona has on concrete repairs, and the majority of you voted for 102. But in fact, I can announce that we have 508 case studies all about concrete available on that website, khia.belzona.com. So although we don't have time to talk about all 508 of them, right now we're going to focus on 4, which we think really highlight some of the features we just put to the test in that video.
Okay, so the first case study we're going to go through is to do with the floor areas. So the one thing we're looking for from a product to repair a floor area is mainly long-term durability. You want to be able to apply the product onto the floor and to leave it to do its job for a considerable amount of time after the application. So the first one we're looking at is inside the freezer of a meat factory. So this is a good example of the type of damage you find literally all over the world in large industrial areas which are built primarily out of concrete. So the concrete we're actually looking at inside the freezer on the picture is about 40 years old. So considering the service time it's been in for, it hasn't actually done that badly. However, if the customer left this completely untreated, obviously it's going to cause some significant problems in the future. When we faced the customer and said, well, how are we going to go about doing this? They said, well, we've got 3 issues we need to overcome first. The first one was they needed 24/7 forklift access to the area. Second problem was that there was multiple areas, so it's not just the one. And they also only had 3 days to complete the application. Obviously, using concrete to fix this, you'd have to have that minimum 28-day cure time before you get your mechanical strength to allow this to go back into service. Obviously, that's unacceptable throughout the 3-day window. So Belzona was chosen, and the first stage of any application is normally surface prep. So we're looking for a surface which is clean, a surface which is dry, and a surface which is firm. In this case, roughness is not required because the surface was rough enough already. So you avoid the need to use machines which may incorporate difficulties in terms of hand-arm vibration values or HAV values. So that was avoided completely. The product itself we used was Belzona 4154, bulk fill resins and an aggregate to pack out the main section of the repair itself. And then Belzona 4111 was applied on top of that surface to give you your mechanical properties, compressive strength, tensile strength, impact resistance, and general dilute chemical resistance as well. Now we'll move away from the floor areas to secondary containment. So this could be a bund or a secondary storage where if something leaks out of a primary storage tank, it goes into this area. So the one thing we're looking for mainly is excellent chemical resistance from our products. The application we're going to look at is a solvent extraction plant in a mining facility. So what they had was they removed the copper ore out in the mine, and you find that you've got the copper in with lots of different impurities. In order to extract this copper, they dilute it dissolve it into sulfuric acid. Obviously, introducing sulfuric acid into concrete is never a fantastic idea. Over time, it will break down and wear away. So the 2 problems they faced with this, one was the sulfuric acid, and the second one was that they had this sulfuric acid mix at 50 degrees centigrade. So it's not a cold mixture either. And as we know, the hotter the chemical gets, generally the more reactive it tends to get. So the concrete was beginning to break down over time. And once it broke down enough, eventually that sulfuric acid could find its way deeper and deeper into concrete and cause more severe damage to it. So it seems like quite a complicated issue. But fortunately, the repair was relatively straightforward. Again, after surface preparation, clean, dry and firm, Belzona 4111 was used to restructure the concrete. Anything that was damaged or anything which needed rebuilding back to its original profile was rebuilt using 4111. And then Belzona 4341 was used, which is designed for hot inorganic acids to protect the surface from further damage. So this prevented the sulfuric acid from even getting to the concrete or getting to the Belzona underneath in the first place. And if you can prevent it from getting there in the first place, you prevent the damage from happening. The customer was so happy at the end, after the coating job was finished, that they actually supplied this and applied this onto 100 other containment cells as well, just proving that the solution was one which they were very much looking to invest in because it was a workable solution.
So next we're going to be looking at a case study where a solution was needed which would be able to bond to cracked concrete, as previous traditional repair attempts had failed due to poor adhesion. So this was at a church property where a balcony was seeing cracks due to its natural movement over time, and these cracks were allowing water to seep into the substrate. Originally, the client tried to repair the balconies with a sand and cement mixture. However, the adhesion of these materials was simply not good enough and they failed. The client wanted a solution which would be long-term and cost-effective, so turned to Belzona. For this application, the screed solution was specified, Belzona 4131. This was because of its outstanding adhesion and ability to feather edge, so this was used to repair the cracks. And then to fully waterproof the balcony, Belzona 5811 was coated on top. This also left an aesthetically pleasing finish on the balcony. And finally, we've reached the top of the building, ceilings and vertical walls. And we're going to be looking at our material, Belzona 4141, which has excellent lightweight properties. So as you heard in the video, Belzona can repair vertical damage of up to 127 millimeters and overhead damage up to 76 millimeters. And this is with minimal or no former usage. And these properties made Belzona 4141 an ideal solution for this case study at a severely damaged office building where hundreds of repairs were needed. So at this office, literal chunks of concrete were falling down from the facade, which is obviously a massive health and safety risk. A full repair was necessary, which Belzona was able to provide with just the one product, Belzona 4141. In total, over 300 vertical and overhead repairs took place around the building over about 3 months of working weekends only, which is quite fast considering. And then the office was completely restored, with minimal disruption to its everyday operation. A final reason Belzona 4141 was chosen was because it can be tinted. So in this instance, the red tint ensured the system blended into the office's facade, and these repairs were barely even visible.
So all of these case studies that we've just been through, all of these products that we've suggested already, they all have their own individual merits. So 4141 is lightweight, 4341 is chemically resistant, 4131 is abrasion resistant, impact resistant, that sort of thing. But a lot of these products also share common features throughout as well. So most of the products are two-part materials with relatively easy to follow mixing ratios. There's no volatile components inside the products. They all exhibit good mechanical strength. The magma polymer screeds can be feather edged. So it's not a case of every single product has a very specific use. And they are good generally across the board, but also having specific areas like the 4141 lightweight, where they can be used for very, very specific problems. Now, if you're confused about maybe a product or a type of application, and you wanted more information, we have the Belzona website, but we also have the Belzona TV YouTube channel. It's a very, very good source of information. Currently, there's different videos on different types of applications, ones that are product specific. There's the In Action series, which is related to our case studies. So rather than just still images, you get a video relating to the case study as well to tell you from start to finish how they've completed the application. And we also have the how-to series, which is for specific jobs, what products you need to use, preparation, application, mixing, everything you possibly need to know. And if you maybe need it in another language, a lot of these videos are also offered in the languages you can see in the bottom right of the screen at the moment. So chances are that there's going to be a video for you guys if you're using a Belzona product in the near future.
The latest video to be put onto the YouTube channel is that Belzona versus concrete put it to the test we just showed you. So it was a world exclusive when we showed it you before, but it's now available at youtube.com/Belzona TV if you'd like to watch it again. So we hope we've given you a good overview of some of Belzona's 100% solids epoxies and how they can be used to effectively repair concrete from floor to ceiling. If you want more information after our Q&A session, you can check out the website. There you'll find links to your local Belzona distributor. As you can see by the map, we are well represented all around the world. But regardless of whether there's a little flag in your country, there'll always be someone dedicated to helping your region with our materials. So thank you for watching, and now it's time for our Q&A session. So I'd like to introduce Belzona's Commercial Director, Steve Cooper, to help answer some of your questions. Okay, so the first question we have today is, what was the preparation utilised for the cell repairs, which looked to be a result of rebar corrosion?
For the seal repairs for the 4141 repairs. So preparation-wise is just removing anything loose from the surface, and when you had the corrosion on the rebar itself, normally we'd go behind the rebar to make sure we get all the corrosion, the loose rust off of the rebar itself. And then that means that when we put the conditioner and the actual product, Belzona 4141, on the surface, it kind of seals the entire rebar rather than just that front edge. So it prevents that section from corroding again because it's then surrounded. So if the surface isn't roughened already, we'd roughen it initially, but it's making sure that it's all clean and firm and there's no remaining corrosion on the rebar itself.
I hope that answered your question. Are there any other questions? How quickly can all of the products be applied and back in use?
Depends on the product, really.
Well, yeah, each product has a different cure time. Obviously, temperature affects that as well, and also the service it's going into, whether it's regular use, whether it's chemical contact. What we always recommend is that everybody uses the instructions for use leaflet when using the product, and it's got a detailed list on there of cure times and back in service times for each product.
Okay. So, if there's any other questions, if you could type them into the chat now. Otherwise, we'll wrap up this Solve It session webinar. Just wait a minute to see if anyone's typing now. Do you agree with that?
Yeah, I'd agree with Rama's suggestion. So yeah, because they cure via an exotherm. So if you have a thicker section of product, then it generates more of an exotherm. And the more heat you have, the quicker the cure goes. So yeah, if you apply it in a thicker section, generally it does cure quicker. But we do, for some products, specify, like the coatings, they have to be a certain thickness in order to perform correctly. So for the magma polymer, like the 4131 or 4141, they can be applied normally at different thicknesses. So yeah, in that case, they would go faster if they were applied in a thicker section.
Okay, so I had a customer yesterday who needs 4141 as they cannot suffer HAV anymore. 2 days to flat repair.
Yeah, I think I mentioned it briefly. So some of the repairs, we require a rough surface in the first place. But if you have an already rough surface, the conditioner gives you a lot of the adhesion. So what you tend to find is that the need for roughening is minimal. So you won't need to use the big machines. You don't need to worry about hand-arm vibration issues at all. Yeah, because obviously hand-arm vibration is a big issue. Most of the machines you can only use for an hour maximum per day. So you're quite limited, hence why it took them 2 days to do the prep in the first place. And then for a 4141 repair, if you're doing an overhead, it's again quite difficult to get the machines to the area in the first place to do the repair. So you want minimal preparation time, but as long as you've got the clean, dry, firm that we always ask for, then you can apply the 4141 with the minimal roughening of the surface as well.
Surface preparation is reduced because you can feather edge the materials, so there's no need to cut out and cut back or rebake concrete to a shouldered edge to infill. So as long as Henry says, it's clean, dry and firm, you can use the material and feather edge it to a finish.
We've had a question, how to repair dynamic crack in concrete with your product?
What's the question?
So that.
So I guess that means if you've got a crack that's still propagating in concrete.
Yeah, I mean, I don't know the context of the question necessarily, but if you've got, you would need to terminate. You would need to make sure you've terminated the crack. Don't know whether the person asking the question can send in some more details about the application or photographs. But yeah, if there's a potential for a crack to continue, you would want to terminate the crack before you attempt to repair.
Okay, so I think that's all of the questions for now. So thank you all for attending. There'll be a recording of this webinar available on the blog, which is blog.belzona.com. But thank you for attending, and we'll see you soon.